So section 2 is all about automation for scale-out applications using, again, your VMware vSphere environment. Right, and this is a good continuation coming from our section 1, which was all about transforming that vSphere setup into an Amazon-like cloud. Well, when you think about Amazon-like cloud and when you think about developers who are wanting to use it, or DevOps engineers, they're all about applications, right? They want to be able to quickly deploy their applications, and then they want to take it one step further, and they want to start orchestrating advanced applications that consist of multiple VMs, multiple tiers, etc. And when you think of that, the first thing that comes to mind typically is Amazon CloudFormations. Right, CloudFormations is this really powerful tool that Amazon offers that lets you describe and compose these multi-tier applications, and then describe policies around them. So OpenStack has been very heavily inspired by Amazon. So OpenStack has a construct called OpenStack Heap, which is modeled after Amazon CloudFormations. And so it has its own format, its own language, which is YAML-based for describing of these multi-VM, multi-tier applications, and then describing all kinds of policies around them. Right, so that's what we're going to focus on in this section. I have another demo environment. And we're going to use this environment to demonstrate how Platform9 managed OpenStack lets you define and orchestrate these multi-VM, multi-tier apps on top of your existing vSphere resources. So the first thing we are going to do in this environment, and this is again paired with VMware vSphere resources. I think I have one cluster that's paired with this particular Platform9 environment. And what I'm going to do next is I'm going to go ahead and deploy a new heat stack. So a heat stack is nothing but a definition of a multi-VM, multi-tier application, right? So we're about to create a new heat stack. There are templates freely available on the internet for creating different types of heat application, heat stacks. So we've chosen one such template. What we have is, let me just get out of the full screen here. What I have here as an example is a heat template that consists of WordPress application paired with a load balancer. So the load balancer is going to be balancing input requests across multiple instances of WordPress application. And then I have some auto-scaling policies that are defined around this WordPress application. So let me start by deploying this template. So all I got to do in the Platform9 interface is drag and drop these heat template metadata files. The autoscaling.yaml, that's the main file for the template, and the two supplementary files are HAProxy and WordPress server.yaml. And we're going to look into exactly what these files describe in just a second. Okay, so what I'm going to do is I'm going to go ahead and specify some parameters for this template. So each heat template gives you the ability to specify some input parameters. And these would be describing some dynamic properties that you want to supply to the template on demand. So, for example, we are giving this template a network that it should use to deploy its virtual machines on, and then we are giving it some OpenStack properties because the template actually internally talks to OpenStack Ceilometer. So I'm going to go ahead and give this template a name. I'm going to call it stack test. I'm going to give it a 60-minute timeout. And then I'm going to say launch the stack, right? And now we've created the stack, and you will see that the stack creation will be in progress. This takes usually a few minutes of time because the underlying virtual machines will get deployed. They will come up, they'll get an IP address, then they'll talk to each other. So it takes a little bit of time. So in interest of time, we're not going to wait for that to happen. I'm going to switch to an environment which had a pre-created stack with the same template that I had created before, and I had deployed it, and this stack has been created successfully. And so as I switch to instances view, you will see that there are 3 virtual machines corresponding to the stack that got deployed when the stack got created. The bottom one is an HAProxy VM, so that's the load balancer, right? And then that is paired with 2 virtual machines, which are each an instance of a WordPress server. Mm-hmm. So this is a simple example of a tiered application, right? So this application is now deployed by simply deploying that heat template YAML specification, right? And then as it got deployed, it knew what image to select, what flavor to apply, what network to connect to, also what script to execute. So we had given it a script to execute once these VMs were launched, and all that was all wired up, very nicely by OpenStack Heat. So now that this template is deployed, I'm actually going to do something interesting. I have this little Chrome plugin, which is testing for response time from this WordPress application. Okay, so when I start by testing for response time, right now the response time is about 800, 900 milliseconds or so. I think the latency is a little bit high here because the network is not that great. But what I'm going to do now is, with this template running, I'm actually going to simulate a benchmark test using my computer. So what I'm going to do is, I have this AB tool running on my Mac. I'm going to give it some concurrency parameters and ask it to just fire away and send a bunch of requests to this WordPress template. Okay, so that's what we started. We're simulating some workload on this WordPress template. And as we do that, let me make sure I am on VPN. Yes. So we've started simulating the workload, and as I go back here, you would see that the latency has really started overshooting, right? So the response time has gone into 2090 milliseconds or so, and pretty quickly this will start timing out. So what's happening is that this WordPress is now being hammered by a number of requests. And the reason why I'm doing this is because when we deployed this template, we also coupled it with some auto-scaling policies. Okay, so what we had said is actually what I'm going to demonstrate to you over here. So I have OpenStack Ceilometer running here, and I'm going to ask it to query for any alarms that were registered in the context of this heat template. And you can see, I know it's a little bit difficult to see here, but you can see that there are 2 Ceilometer alarms that have been registered at the bottom. And so what is this showing is that as part of that template, we had set up some high threshold for CPU utilization and some low threshold for CPU utilization. And we had said if the average utilization across these WordPress servers goes above 50%, then start firing up a new instance of WordPress. Okay, so let's see if that has happened yet. It'll take about a few minutes as this test runs and starts firing up requests in tens of thousands. Eventually the alarm will hit, and at that point you will see that a new instance of the WordPress server will get fired. So the alarms are still in OK state. This indicates the state of the alarms. The moment one of these alarms goes in an alarm state, that's when a trigger happens and that trigger is acted on. So we should see that in a matter of a couple of minutes, hopefully. So this is really the power of OpenStack, right? This is the power of Heat, which is what we did was we took our existing vSphere infrastructure and we literally transformed it in a next generation DevOps friendly stack or setup.
So, Madhura, while you're waiting for that, if I can just add a couple of points.
Yes, please.
Well, firstly, by the way, I don't know if the network here is fat enough to actually push that VM over the cliff.
Yeah.
So it depends on whether your network is actually is the network going to choke before that VM chokes, right? So we're a little contingent on that. But I think the larger point that we're making is that when you think about modern applications, they're scale-out applications. There's many different patterns that are common to these applications. So you tend to have multi-node deployments. You tend to need to place these nodes for performance across individual failure zones for performance and availability reasons. You want to integrate these with load balancers. You want to have dynamically scaled out and scaled down horizontally scalable applications. And the point here is that using a vSphere-based environment, all of those capabilities are available to anyone who has vSphere, really. And this is an opportunity to leverage these innovations that have happened in OpenStack, which are essentially bringing this public cloud innovations, but they are also available to use with a vSphere environment or a Linux environment, for that matter. So I just want to share that perspective, Madhura, while you're waiting for the VM to go over the cliff.
Yep. Yeah, so like she said, I'm not sure if this alarm is going to get triggered this time. We'll give it a couple of seconds. If not, we'll just say that this does work in real-time scenarios. But
Just question.
Yeah.
So you explained this is really cool in terms of it's showing an elastic kind of deployment for these companies that need this kind of scale up, scale down. So can you go the other way? So if the CPU is too low and you've got all these deployments, will heat do
Yeah.
that as well?
it will. In fact, if we had enough time, I could have demonstrated that as well. But let me show you the policies the way they're defined, right? So this is the CPU alarm high and CPU alarm low policy. And the low policy describes that if the CPU utilization goes above 15%, then take down one of the instances. And it'll actually do that.
Good.
So it's pretty powerful. So the way this is working behind the scenes is it's taking OpenStack heat and then it's pairing it with OpenStack Ceilometer. And Ceilometer is another component of OpenStack, which is really focused in gathering metering data. So it gathers all kinds of data around CPU, memory, storage, network utilization, allocation, etc., and it just collects that. And then heat works with Ceilometer to be able to register some alarms and be able to register triggers on those. So that's how things are working behind the scenes.
So do you guys have integrations with third-party load balancers built into the product?
Right, that's a good question. So not yet, right? But that is part of the roadmap. One of the first things we're going to do is, if you see here, this is an HA proxy VM that we put in, right? Neutron with OpenStack comes with its own load balancer, and as we're working on that integration, we're going to enable that.
It'll be visible in the
correct. So at that point, actually, Heat has built-in integration with that load balancer, so you don't even see it as a VM or anything. It's just an internal component.